Homework 6 is more naming practice. So first thing we got to do is figure out if it is ionic, molecular, or acid. Then I want you to highlight the polyatomic ions green and circle the cations that can have more than one charge. So these are, of course, going to be our transition metals. And also tin and lead. Highlight acidic hydrogens in pink. So any hydrogens that are from an acid, those are going to be pink. And then write the name or the formula. So to figure out if something is ionic, molecular, or an acid, an ionic compound is going to be a metal and a nonmetal, or it has a polyatomic ion. A molecular or covalent compound is going to be just nonmetals. And an acid is going to be something that either begins with hydrogen in the formula or the name ends with the word acid. So let's start. For this one, I have tricarbon octafluoride. So this is going to be molecular or covalent. And I know that because I've got my prefixes. So this one's going to be really easy to name. Tricarbon is C3. Octafluoride is F8. Okay, the next one, we've got NiO2. So Ni is a transition metal, which means I don't know the charge of it just by looking at the table of elements. So I want to circle that one because it is a transition metal. I've got a transition metal and a nonmetal, which makes this ionic. So in order to name this, I know that Ni is nickel. And because nickel is a transition metal, I need to figure out what its charge is. So I don't know the charge of nickel, but if I look on my table of elements, the charge on oxygen is -2. So there's 2 oxygens, and each of them have a -2 charge. So my total negative charge is -4. So then my positive charge to balance that must be +4. There's only one nickel, so the charge on this nickel has to be 4. This is O, which is oxygen, but we changed that to oxide. Okay, the next one, hydroselenic acid. We know that's an acid because we've got the word acid there. So whenever I write out this formula, I need to check to see what the form is. So I've got a hydrobromic acid, which means that this stem in here originally ended with "ide." So this was originally selenide. So selenide would be selenium. So that's Se. And I know that since this is an acid, it's going to start with H. With acids, you want to check your charges to make sure they're balanced. So for selenium, the charge on that is -2. And the charge on hydrogen is +2 or +1. So whenever I crisscross, I'm going to get H2. That gives me a +2 charge. Se1, which gives me a -2 charge. So my formula is just H2Se, hydroselenic acid. So since we have an acidic hydrogen, that's going to be that guy. So this hydro in this name, this is kind of referring to that acid. Next one, I've got H3PO4. So H3 starts with hydrogen, which means that this is acid. So I have to look at this thing that isn't hydrogen. In this case, it's PO4, and I got to figure out what the name of that is. So I've got hydrogen, phosphorus, and oxygen, 3 different kinds of atoms. So that gives me a hint that I have a polyatomic ion. So my polyatomic ion here is going to be PO4, which is phosphate. So I know I've got phosphate. If I look at my card, if something ends with 8, that means I'm going to name it as blankic acid. So this is going to be, instead of the blank, phosphoric acid. Now phosphorus is also one of the weird ones, like sulfur. So technically it should be phosphoric acid, but if you had phosphoric acid, I wouldn't mark that as incorrect. Next one I have is Cobalt Two Hydroxide. So this has got a lot of stuff going on. Number one, I've got cobalt, which is a transition metal. So it can have more than one charge, so I need to circle it. I've also got some polyatomic ion. I've got hydroxide. Oh, and by the way, in the last one, that PO4 was polyatomic. So I've got a transition metal and a polyatomic ion. So this is going to be an ionic compound. So cobalt is CO. The charge on cobalt is +2. I know that from the Roman numerals. Hydroxide is a polyatomic ion. It's OH with a -1 charge. So whenever I crisscross my charges, this gives me, hydroxide has a -1 charge, but there's 2 of them, so that gives me -2. And cobalt has a +2 charge, and there's 1 of them, so that gives me +2. So that means that when everything's all said and done, here's my formula, COOH2. So that guy is polyatomic. And of course, cobalt is transition. Next one I have is HCN. So it's starting with an acid, or starting with a hydrogen, which means that I've got an acid. So I need to look at the thing that isn't hydrogen. So I've got hydrogen, carbon, and nitrogen. 3 different atoms tells me that one of these is a polyatomic ion. So in this case, my polyatomic ion is going to be CN. So I get my polyatomic ion sheet, and I see that CN is cyanide. It ends with IDE. So the stem that's going to fit with that is Hydrobromic Acid. So the blank is going to be cyan, so it's hydrocyanic acid. Next up I have sodium phosphate. This is ending with an ATE, which means that this is going to be a polyatomic ion. And sodium is a metal, so this is ionic. So sodium is Na with a +1 charge. Phosphate, I need to find the formula for. So the formula for phosphate is PO4, and its charge is -3. So whenever I crisscross my charges, there's 3 sodiums and they're each +1. So that gives me +3. And this side is -3. So my formula is Na3PO4. The next one, I've got carbon and fluorine. So that means that this compound is going to be molecular because I have a nonmetal and another nonmetal. So the way we name this is with our prefixes. So I've got carbon, and there's 1 of them, but remember we never start with mono. So this is just carbon. Fluorine becomes fluoride. There's 4 of them, so that's tetrafluoride. Next one that I have on here is potassium dichromate. So this one ends with ATE, which is a sign that it is polyatomic. And I've got potassium, so a metal and a polyatomic ion means that this is ionic. So potassium is going to be K, and the charge on potassium is +1. And then I've got dichromate. So since that's a polyatomic ion, I need to find it on my sheet. So I'm going to need to crisscross my charges. The 2 comes down here, the 1 comes down here. So this gives me a +2 charge on this side and a -2 on this side. So I've got K2Cr2O7, potassium dichromate. So the back starts out, we've got magnesium, which is a metal, and then I've got a polyatomic ion here, ClO. So I need to go look up Mg, which is magnesium, and ClO is the polyatomic ion hypochlorite. And I know that because we can look this up on the table of elements. So this is a metal and a polyatomic ion, which means once again it's ionic. Copper 1 oxide. So copper is a transition metal, so I need to circle that. And because I've got a transition metal and a non-metal, this is ionic. So Cu with a +1 charge. Oxide is oxygen with a -2 charge. So whenever I crisscross my charges here, this will give me +2 on this side, -2 on this side. So my formula is Cu2O. Next, I have iron and arsenic. So iron is a transition metal, arsenic is a nonmetal. So this one's going to be ionic. So I don't know the charge of iron, which means that I got to figure out what it is and indicate that with Roman numerals. So the charge on iron, I don't know, but the charge on arsenic I do know. The charge on arsenic is -3. Now there's 2 of them, so that gives me a charge of -6, which means the positive charge is +6. So the total positive charge on this iron is +6, but there's 3 of them, which means that each iron must be +2. So this is going to be iron 2, and then arsenic becomes arsenide. Iron 3 cyanide. Iron is Fe with a +3 charge, because it tells me. Cyanide is a polyatomic ion. So the formula for cyanide we need to look up on the back of our sheet. It is Cn with a -1 charge. So charge over here is -1. So whenever I crisscross, this 3 comes over to cyanide and this 1 goes with iron. So we get Fe, cyanide, and there's 3 of them. This is an ionic compound. Next I have AuF. Au is a transition metal. So that means that whenever I write my formula, I'm going to need to have Roman numerals. So Au is going to be gold. And I need to figure out what the charge is on gold. So fluorine, I can look up that charge. Fluorine is a charge of -1, and there's 3 of them. So this gives me a charge of -3. This means that my positive charge has to be +3, and there's only 1 gold, so the charge on that gold is 3. Fluorine becomes fluoride. This is an ionic compound. Okay, next I have titanium 4 acetate. So that can have more than 1 possible charge. So I need to circle it. And acetate, it ends with ATE, is a polyatomic ion. So I have a metal and a polyatomic ion, makes this ionic. So titanium here is going to be +4. And acetate, if I look up the charge, is -1. So whenever I crisscross, I need to have 1 titanium, and I'm going to have 4 acetates. Next one is RuNO3. So Ru is a transition metal, and nitrate NO3 is a polyatomic ion, which means this compound is ionic. So the name of this, of Ru, is ruthenium. And now I got to figure out the charge. So the charge on nitrate is going to be -1, but there's 3 of them. So the total negative charge is -3. So my positive charge must be +3, and there's only one Ru, so the charge on that is 3. So ruthenium-3 and NO3 is nitrate. All right, now I've got an acid. And the form of this is blank-ic acid, which means that my ending, before we changed it, would have been 8. So this was originally sulfate. So sulfate ends with ATE, is a polyatomic ion. So that's going to be SO4 with a -2 charge. It's an acid, so we put hydrogen in front. That's +1. So I need to crisscross. So I get H2SO4. Next up I have H2SO3. So SO3 is a polyatomic ion, and its name is sulfite. So whenever you have an ITE, that's going to change to blank-us acid. So this is going to be sulfur us acid. If you just had sulfus acid, that would be okay too, but remember, sulfur's weird. So that was an acid. Next I have carbonic acid, so obviously an acid there. And this carbon here is a blank-ic acid, which means that the carbon originally ended with 8. So this was originally carbonate. So I got to look up my formula for carbonate. That would be CO3 with a -2 charge. We put hydrogen in front because it's an acid. So if we crisscross our charges, I get H2CO3, carbonic acid. Next up, this one starts with an H. So by the way, for all these acids, I didn't highlight them, but because they're acids, I know that there's kind of this unspoken hydrogen here. So for this next one, I have H2S. So this thing over here, the name of that is going to be sulfur becomes sulfide. So this is going to be hydrosulfuric acid. If you had hydrosulfic acid, that would still be correct. Okay, next I have hydrobromic acid. So there's that unspoken hydrogen there. And this is an acid. So I have hydroblank-ic acid, which means that this brome was originally bromide. So bromide is Br-1. It's a hydrogen, so hydrogen goes on top. It's 1-to-1, so whenever I crisscross, we're just going to get HBr, hydrobromic acid. Last one on the page, I've got gold, which is a transition metal, and oxygen. So because I have a metal and a non-metal, this is ionic. I don't know the charge on gold, so I have to figure it out. Oxygen has a charge of -2, and there's only one of them, so my total negative charge is -2. My total positive charge must be +2, and there's only one gold, so the charge on that gold is gold 2, oxygen becomes oxide. So just to review, an ionic compound is going to be a metal and a nonmetal, or we've got a polyatomic ion, and I always want these to be neutral. So I can do this by crisscrossing, but you should always just double check to make sure that your charges are neutral whenever you crisscross. I need to use Romans for uncertain charges, so that's specific for transition metals, and change the anion to end with "ide." Now there are some transition metals that have only one possible charge, so these ones wouldn't need Roman numerals: silver, cadmium, and zinc. Silver's +1, cadmium and zinc are both -1. Then we've got our molecular, aka covalent compounds. So these are going to be two nonmetals, and in this case we need to use our prefixes: mono, di, tri, etc. We need to change the second nonmetal to end with "ide," and we never want to start with mono. Lastly, acids. So it's either going to start with hydrogen or end with acid. And I want to look at the name of the anion, and that tells me which stem I need to use in order to name my acid. And just like ionic compounds, we want to ensure that these are neutral.